there are no questions, thank you very much, and we're moving on to the next report. We have two more reports dedicated to UAVs, unmanned aerial vehicles. Thank you very much. The first presenter on UAVs would be Amir Valiev, Managing Director from AFM-Servers. This is the Russian-based company which is mass-producing UAVs for aerial photography. You have 20 minutes.
Hello, ladies and gentlemen. I have been introduced to you. Well, it's not like we've been mass-producing it for a long time. We are new to this, but I would like to break my presentation into two major parts. First, I will tell you about the status quo of UAV production in Russia and what are the possible prospects for technology development and use prospects given changes in regulation and legislation. These are all interconnected things because UAV usage is a new thing, very relevant. First of all, let's talk about terminology. There are established terms and non-established terms. We used to use the term BPLA in Russian. Now BLA is an established term, and BAK is unmanned aerial system. Also, there are some unestablished terms like manned aircraft. Other abbreviations are not that important right now. Also, there are certain concerns surrounding the use or types of UAVs. At the moment, there are aircraft, multi-rotor, and helicopter. Why do they go in this order? It's because in terms of amount of work they do, multi-rotor system is in the lead for vertical liftoff. They are easier to use compared to helicopter, which has vibrations. Also, there is legislation in place available in Europe, and similar changes will follow in Russian aerial code, whereby multi-rotor systems will be used without having to obtain a license to use airspace. Also, there is a classification by energy source. At the moment, there are two primary sources. This is gas or fuel, and battery ones. A third promising energy source are fuel cells, which in many ways exceed fuel analogs. At the moment they are quite expensive, and it can be afforded by either military or those who have a lot of money. But those who have a lot of money typically don't spend it on fuel cells. Also, there is classification by injury, potential damage rather. It's just there is a possibility of collision between UAVs, manned vehicles, and on-the-ground structures and people. So there is a classification here as well. There is Gatewing UAV, well-known, lightweight, made by EPP. Extensive research showed that it has little kinetic energy. Even if it hits a person, collides with a person, the damage will be insignificant. Well, there'll be no damage, no injury. So there are UAVs that can potentially bring harm or no harm to people. there are dangerous UAVs that, if they collide with another airplane or people, may hurt people. As an example, I cited Horizont, which weighs about 20 kilograms. On this colorful slide, I, by the way, forgot to mention something here. The title marked in red is something that we have now. The red color indicates the potential future, something that may emerge in the near future. So if we look at these slides carefully, we will see that there are certain events that have already set in and certain elements that haven't come yet. At the moment, according to Law 315, it is possible to establish own rules and regulations for application of UAVs. A new aviation code is supposed to come out soon in Russia, and it will have one of the sections dealing with UAVs and requirements that apply. The requirements apply to UAVs weighing 30 kilograms and more. I don't know why they used this threshold, but with this law coming into effect, all UAVs weighing over 30 kilograms will require the same amount of effort you need to get a license to fly, with one exception, that there will be fewer requirements in terms of crew safety, since there is no crew, it's unmanned. But all the other requirements relating to reliability of the device, flying over cities, populated areas, potential collisions with other planes, that will involve the same amount of complexity and challenges that any other modern manned aircraft need. So I assume that the cost of UAV industry and the cost of UAV units will increase dramatically. For those weighing under 30 kilograms, there are self-regulations. For various aerial survey applications, I think 99% of that is done by UAVs weighing under 30 kilograms. And since they are not covered by law, we want to make it as cost efficient as possible, with all the safety regulations taken care of. So a number of requirements are being put forward from this organization. First of all, you need to have a license number or registration number for each UAV used and registered. Then you need to insure against damage for third parties. It's quite possible, and it ensues implicitly from the existing aviation code. It's also possible to have collective insurance where the size of the fee will be 4 times as less compared to individual insurance, and that insurance policy will have higher coverage compared to individual one. Also, a UAV operator is in effect the captain of the aircraft, with all the responsibilities attached to it. UAV is, of course, a lot easier to navigate. Typically, you don't have to have any skills at all because it's a flying robot. And what an operator needs to know? An operator needs to know everything connected with how to interact, communicate with the tower, how to organize rescue effort in case an emergency has taken place. These rules haven't been established yet, but one thing is certain: there is no need to organize flight training. I mean, like roles and pitches, this sort of thing. So the focus of training of operators of UAV will be on safety issues. In Russia, Europe and Americas alike, they use UAVs in so-called segregated space. It means that nobody else can fly in this space. The lower echelon is highly filled with a lot of aircraft, and therefore it becomes very difficult to obtain a license. And as far as I know, you have to pay for it. In Russia, we do flying according to Russian laws, have been doing it for 5 years. We obtain a formal license to use aerial space, and we haven't paid a penny. We only sent letters of congratulations on some public holidays. That's how it all started. Besides, in Europe, anything lower than 100 meters is totally free. If you fly under 100 meters ceiling, you don't have to apply for permission. That allows using multi-rotor systems used for 3D modeling. But multi-rotor systems have short flight time, and the amount of work they can perform is very limited. I know that power lines are now under heavy examination by UAVs. It's when they fly, hover, and examine power lines. A variety of experiments is being carried out on 3D modeling, but it's not used massively yet. In Russia, there is another finer point. We don't have a lot of lightweight UAVs. Besides, you have to obtain a permission for aerial survey. You have to go to the general staff. You have to know how to deal with confidentiality, secrecy. It's very identical to what you have to do when you perform high-altitude aerial survey. And that introduces a lot of challenges to our work. When the customer comes to us, we have to spend 2 months to get all the permissions to do the survey. And sometimes they need work done in 2 days. Now, what needs to be done to ensure high quality and accuracy of aerial survey? This slide enumerates all the requirements put forward to UAVs. On a separate note, let me tell you that the use of a high-accuracy GPS receiver, when the roll angle is more than 15 degrees, there is a loss of satellite decision. And when we talk about satellite objects, if the roll angle is above 15 degrees, special antennas are used, diagonal antennas, that keep the roll under 15 degrees, and we get good trajectories without any damage done to accuracy. If this roll angle is higher, greater than that, then we lose ephemerates. One could say that the use of such guidelines and recommendations leads to a possible center of photographing with 4 to 5 centimeter accuracy. Now, you need to have about 80% of forward overlap, because if that and 70% of side overlap. If it's greater than that, then you have to do a lot manually. And with UNVs, the size of frame is much smaller than professional cameras. Because of that, you have to have great overlaps. Redundant overlaps provide other advantages, in particular more convenient interpretation, easy interpretation, and a few other additional accuracy. Although what UAVs have to provide are no comparison to what larger aerial photography can offer. Now, as far as the shift compensation or the angle compensation is concerned, we noticed that many software developers pay little attention to how the wind affects the movement of UAV. Sometimes we had to deal with this angle being greater than 35 degrees. We use Nikon D800. This is a camera that has some specific features, but recently we have come by a household camera, amateur camera with good. It costs about 500,000 rubles, and it just so happened that Sony released a small size 35mm fixed lens camera that has a full frame 36 by 24 frame array, so we can use it for our UAVs, 20 kilograms, and more lightweight devices. Camera requirements are shown on the slide. You have to have a fixed lens and the fixed focus, because when focus can be adjusted, it leads to loss of accuracy. You need to immobilize focus, setting it at a certain level. In our case, it's 100 meters, and that allows us to use it for power lines survey from the height all the way to the height of 1 kilometer. I tried to set it at 60 meters, the focus, but for some reason the result was not that great. Another way to use UAVs is to put them in a non-segregated aerial space. For that, we took initiative to put forward a proposal so that well, it's kind of a dubious or controversial proposal. We know that in Europe they use radio communication in power line range, and some pilots that use lightweight aviation know that there is a certain frequency, and this is a similar situation when UAVs can communicate simply to warn that UNV is within close range. In Russia, we use automatically dependent broadcasting. The purpose of this technology is that any UAV may have a GPS receiver mounted, and it will transmit all the location-related information. By law, it will be introduced as an obligation in 2020 in the States, in Europe in 2025, and in Russia the same. This is a fairly distant future. So it is possible to go about it by using other techniques. One of them is SBD, since there is no way to control flight of they use SBD modems. In Canada they use them, for example. And then this data is transmitted centrally to the flight operators' offices across Russia. I know that I'm overstepping the boundaries of my time. One of the key and essential criteria of UAV usage is their cost. There is a critical term, MTBF. That means how long a UAV can fly before it fails. The second factor is warranty, because it's redlined or highlighted in red color, because only now these things become more and more relevant and important. The users need to know that all of that has to be provided to purchase a UAV. The third factor is productivity, and there is a lot of other factors like deployment time, service time between flight, and some cost-related things. The cost of training the crew is a factor that will allow mass use of UAVs. You will be able to make the use of unmanned aviation faster and better. Also, flight missions have now started being put together using one and the same method. There is one other aspect that is not mentioned on this slide. I simply want to show that the cost of processing data from UAV is slightly higher vis-a-vis the manned aviation. But since UAVs hold a certain niche, they will never be able to cover hundreds of thousands of square meters. But if you need to cover 1 to 100 square kilometers, UAVs will be the future, and they will definitely be in the lead. The other part of the presentation will be made by me during the roundtable. If you have any questions, please ask. Let me remind you that on Wednesday, after the lunch, we will have a roundtable dedicated to unmanned aerial vehicles. If you're interested, please join the roundtable to ask your questions.